All right, today's lecture is going to continue the trend that we have seen in the previous lectures where we were uh, creating more and more complex pipelines of streams, okay? And one of the things that we covered last was the ability to structure our pipeline so that we apply a bunch of intermediary operation like map, filters, etc. And then we reduce the end result of the pipeline into one deliverable, one object, one entity, okay? So we are going to see another example of this kind of reduction. But the thing is that with reductions that are used all the time that become common patterns, you don't have to necessarily use the dot reduce method from the class stream that we covered last time. Okay, there are pretty much use cases that are so common and so regularly used by programmers that they have their own actual method to implement them and encapsulate them. Joining elements is one of those use cases, and this is the one we're going to talk about now. So let's start, as we always do, with a very simple problem, okay? And we are going to rewrite it over and over and over again, trying every time to take more benefits from the features of functional Java programming. So our starting point is we want to display our friends collection, which is a list of string. We want to display it on the screen, and we want to put a comma between every name. Okay, so here's an example of code that attempts to do this. So you can see here, let me grab the laser pointer here. You can see that we have an enhanced for loop here for each loop. So for each name that is a string in the collection friends, we just system.out.print that name and put a comma afterward. And when we are done, we print then a carriage return to go to the next line. Okay, so this is really basic. There is one thing that is wrong, however, with that code. The one thing that's wrong is when you run it, you can see that all the names that we had in the collection before are indeed displayed. So we are not really off by one. Okay, our loop is not incorrect. And this is partly due to the fact that, well, we don't use indexes, we just rely on the enhance for loop, so chances of being off by one are nil. But the logic that is a little flawed here is that there is now, trying to go to the next slide, but apparently it's causing problem. There we go. There is now a comma after the last name in the list, and that's not something that we want, right? So we want to display Brian, comma, Nate, comma, etc., blah blah blah, and then Scott, and then we are done. We don't need this extra comma at the end actually of the list. So let's try to fix that. And unfortunately, because, like I already said in previous lecture, because those techniques such as the enhance for loop are there to make simple tasks even simpler, even if you have a simple task, but it's just requiring that little bit of exceptional handling, then suddenly you cannot use anymore those enhance loops. So instead, we're going back here, as you can see, to a traditional for loop in Java, and we use indexes and index I. We initialize it to 0. We have to create a new index variable, initialize it to 0. We have to compare it to friend size -1. So is it -1 here, or is it just friend's size? Is it lesser than, lesser equal? Okay, all of these are source of bugs. Then we need to increment I at the end of each iteration, and then we display friends.get the element in the collection at index I, and then put a comma afterward. And then another extra step we need to do after we are done with this iteration. So we stopped at friends.size -1, right? So we didn't display the last element of the list. Well, if the list was not empty, we are going to display that last element here, but again, we need to compute its index. Maybe we are going to be off by 1 here, we are going to forget to do -1, stuff like that. We can create runtime exception. Okay, we reopen the door to all of the bugs we have been discussing before, and that led us to say, well, those enhance for loops are really great. But unfortunately here, because of that one comma, we have to go back to a low-level version. So obviously, if we use this example, that means that we can do something better, okay, using some of the new features of Java. So let's take a look at what something better would look like. And you can see that this is really, really trivial in comparison, okay? System.out.println, all right? No loop, no indexes, nothing. I just use a join method, which is a static method from the class string, okay? And I use string.join by saying I want to join the elements in the collection friends, and I want to separate them with a comma. So underneath there is a class named a string joiner that is used. You don't even have to worry about that, okay? The only thing I would point out at this point is the dot join method is a method, static method of the class string. It is not a method from any of the stream classes. So in this example, we are actually doing a lot better, okay? We recognize that what we are trying to do is actually a join operation, which is taking every element in a collection and concatenating them with one another. I mean, if the elements are string, then yes, the reduction is concatenation, and separating them with another element, a new element, which is a comma. Okay, so we recognize this is a well-known pattern, well-known operation. We have a method to do that. We get rid completely of using, for loops and doing everything by hand, reinventing the wheel. But we are still using a method from the collection framework, and that means that if we wanted to do what we do usually with streams, which is filtering, mapping, etc., well, we are not yet there. Okay, so that's going to be our next step. Our next step is, well, what about I want to map elements, of that collection. I want to filter them. I want to do all sort of intermediary operation, and then only then I want to do my join operation. Okay. Well, then to do that, we need a terminal stream operation that's going to be called, join, join in, whatever, and that's going to allow us to do the same thing we did on the previous slide, but with the equivalent of a reduce operation on a stream. Okay, so the reduce operation that we're going to use is actually collect. Remember collect, we used it in the past examples to take a stream of entities, of objects, and we used it generally to dump that stream of entities into a traditional Java collection framework. Okay, so collection. So in this case, we're not doing that exactly, okay? We are doing something slightly different, and you can see here that we're calling here a method joining. So if you want to test this example on your system, just make sure that you have the correct import statements, okay? If I remember correctly, joining is defined in the class collectors as a static method. So if you do import collectors .star, you will be able to use joining like that. Otherwise, you'll have to use a fully qualified name, collectors.joining, okay? So how does our code look like? Well, very similar to what we had before in the last version, okay? System.out.println, so we attack directly with, I want to display something. We do not have a loop, we do not have indexes and stuff like that. But this time, instead of calling a method join on the friends collection directly, we first generate a stream from our friends collection. Then we do something with that string. So just for the sake of illustration, in this example, okay, we have mapped to every element of the stream the two uppercase method from the string class. Okay, but we could have multiple intermediary operation, or even no intermediary operation if really all we want to do is join. Okay, once we are done with that stream, we collect every element in that stream, and this time we specify that we want to join them separated by a comma. Okay, so this join operation here, like I mentioned, this is a static method from the collectors class. So what I would invite you to do at this point is it's very important that you look at this documentation that is linked from this slide. Okay, the objective is not for you to memorize all of the method and all the syntax of all of those methods, far from it. But the idea is that you need to read this documentation, pay attention to all the methods that are available and the description of what they are doing. Okay, so just their comments even. Because the idea is that when in an exam or while you are developing an application, you suddenly need to do some specific type of joining operation, or you wonder, can I do this with collect? This is where you are going to go. You're going to immediately open that link. You're going to check, I think I saw a while ago a method that was able to join, for example, string elements, separating them by a comma or whatever I want. Well, if you have this knowledge, even this vague knowledge that there is a method that can do that, that's available, then you can read up the detailed documentation of that method, look at what parameter it takes. So you don't have necessarily to memorize this, but if you do not know, if you do not have an idea of what kind of collectors are available in the Java collection framework and Stream API, then you are not going to even think about using collectors, okay? And that's the danger. So this reading here of this link is not optional. Make sure that you have this bookmarked also for the exam. Next step, well, I mentioned several times that we had pretty much, that joining was just a reduce operation, okay? So the whole point is we could do the same job with a reduce operation. It's just that it's such a common task that it has been encapsulated in a collectors of its own, and we can use that collector, and that just simplify again the notation that allows us to reuse code without the risk of introducing our own errors, since this has been already implemented for us and tested thoroughly by people that have been involved in the development of the Stream API. Okay. So, nonetheless, in order to understand, what's happening under the hood, and in order for you to be able to write your own reduce, if I ask you to do so as the exam, we are going to look at how we could do the same job with reduce. So remember, to be able to write code with the reduce style, okay, by using the reduce method of Stream, you need to understand how the parameters of the lambda that is passed to reduce work. So you always have two parameters, okay? When you start applying reduce to your stream, the first parameter is the first element of the stream, the second is the second element of the stream. And then, once you produce a result from that, that result becomes the first parameter of the second call to the lambda, and the second parameter to the second call to the lambda is the next element in the stream. And from that point on, as we illustrated visually before in the slides, it just keeps sliding over the rest of the stream. So we have seen a few reduce operations so far, okay? How would we actually replace the joining operation on string? Our objective is to produce one string out of all of this. If we take the two first elements of the stream, what I want to do is concatenate the first one with a new string containing just a comma, and concatenate at the end of that the second element. And once I have the resulting string, I keep concatenating at the end of it a comma, and then the next element found in the stream. Okay? So how is that going to look like when we actually attempt to code it? Well, there you go. Okay, so it's not complicated. It's exactly what I described in higher level terms, okay? We are calling the concat method on parameter n1. n1 is a string, okay? Remember, our stream generated from friends contains strings. So we call concat and we say, I want to append at the end of the string n1 a comma and a space, okay? And once I have that resulting string, then I want to concatenate at the end of that resulting string whatever string is n2. So the second name, in my stream of friends. And then I keep doing that. So the result of this is going to become n1 for the next call to reduce. And then n2 is going to be the third name in the stream. And I'm going to just put the third name after the string representing the two first names in my stream, and separate all of those by comma always, and keep going. Okay, so you see that a lot of things can be done with the reduce logic. It's just you need to get used to how those parameters are captured in the stream, and once you really understand that, you can do very nifty things with reduce. And as we are going to see later, the advantage of writing code like this based on stream, map, and reduce operation is that if you want to parallelize it, you generally have only to turn on a switch. Okay, you have to say I want a parallel stream from friends instead of a stream, and there you go. Java is going to be able to automatically parallelize those operations for you. Okay, and take benefits of your multi-core architecture. Now we're going to move to the next main part of this lecture. So we have been talking about using lambda expression with strings. We have not talked yet about comparators and filters. So we are going to revisit a little bit the idea of streams, but this time we are going to apply them not to a collection of entire strings, but to a single string. And then we're going to talk about comparators and filters, and that's going to be the end of that section. So first step, we have so far used streams to generate a list of strings. Okay, so for example, we have a collection that is a collection friends, which is a list of strings. We generate a stream of those strings, and then we process every individual string one by one. Well, what if we want to do the same thing, but instead of generating a stream of string objects, we want a stream of characters that are coming from a string. So that has application, for example, if you are like considering files, binary files, and you want to read them byte per byte, okay? Yes, you may want to benefit from everything that we have available in terms of Java streams, okay? But you want to maybe to apply it to 1 byte at a time, okay, as opposed to apply it to a whole object of class string or employee or whatnot. So we are moving away here temporarily from the realm of streams of objects, and we are going back to the realm of streams of primitive Java data types. So here's the problem that we have here. First, good news. Yes, there is actually a method in the class string that allows us to call .chars on a string reference, and it's going to generate a stream for us that represents every character in that string. So for example here, our string is W00T. Okay, we put that string literal object reference into a variable str. Then we call on str chars. So at that point we have a stream of, I'm going to say characters, but you're going to say it's not entirely true. So based on the fact that I have a stream of each of the character in the string right now, I can call for each. And my lambda is just, call system.out.println on my parameter, which I can simplify as is noted here on the second half of the slide by just saying dot for each and pass a method reference to system.out.println, okay, which is the method I want to call on every element of the stream. So nothing new here, all right? But if you pay attention, and if you just run this code even, you're going to see that the result is unexpected. The result is 4 numbers, not 4 characters, 4 numbers. So those 4 numbers represent the way that the characters are encoded, okay? So that means that str.chars method returned to us a stream of int values instead of a stream of what we would have expected, which is a stream of char value. So why did we get a stream of primitive data type int instead of a stream of primitive data type char? Well, we discussed already in the previous sessions that the stream, the traditional stream that we have been using all along, is meant to be a stream of reference data type, so a stream of objects, okay? Now, there are other alternative streams available. We have something called an int stream class, uppercase I, uppercase S, and like you would guess, this is a stream class that is actually containing primitive data type int as element. And then similarly, there is a long stream that contains primitive data types of type long, and there is a double stream that contains primitive data type of type double, okay? But there is no such thing as a char stream, uppercase C, uppercase S, okay? That does not exist. So my guess about why this is not provided is that there's probably less frequent use cases, people that want to have actually stream of primitive data type. Well, first we can do everything we would do with a stream of char, with a stream of int, okay, because internally a char primitive data type is actually of a short unsigned int, primitive data type, okay? So we can represent everything we represent with a char with an int. And also, most of the time when you want to resort to using actually primitive data type streams, it's because you want to optimize your code. You want to speed up, numerical operation. So that's why the primitive data types that are actually encapsulating in their own types of streams are int, long, and double. So bottom line, leaving aside, the why or why don't we have a char stream, class, we have to face the fact that we don't. So in this example, again, this is a very simple task, okay? So there's no complication here stemming from the application domain of what we're trying to do. Our only complication stems from the limitation of Java. All right, so we need to work around those. We need to learn first which limitation exists, and then we need to learn to work around those. So in this case, the main issue is that we need a typecast, okay? So we need to say, all right, I'm going to keep the same code, but when I do my system.out.println, I want to convert the parameter of my lambda, which is an int value, to a char value, primitive data type ASO, and then system.out.println is going to be able to display w00t as we originally intended, okay? Little problem with that. Okay, we can fix our lambda, no problem. But what about that the next step that we had before? That was, well, if my lambda takes a parameter and apply a function to it, why can't I just use a method reference? Well, in this case, it's a little bit trickier, because if you use a method reference, that means that you are going to pass your parameter directly to the method that you referenced and let Java do it, and there's not going to be any typecasting. So we need to add this additional step, which is I need to typecast something. So to get around that limitation, what we have to do here is write, oops, I went too far, sorry. We need to write our own method print char. So we are going to assume that we have a class named iterate string, okay, and inside the class iterate string, I define a static method named print char that takes a character as an int, okay, and then system.out.println it after converting it to a char primitive data type. All right, so now I'm able to do str.chars, get my stream of int primitive data type values, so my int stream, and apply for each to that int stream, and apply to each element the iterate string method, print char method from the iterate string class. And the result is going to be exactly what we expected. Problem with that is, well, this is a little awkward, okay? I'm losing some of the benefits of using method reference and lambda and stuff like that, because now I have to have a class iterate string and I have to have a static method, just for that purpose. It's a little bit cumbersome, okay? So, next possibility, we want to get rid of having to define those extra classes, etc. We want to be able to do our, we want to be able to do our type conversion, typecasting, on the fly. We want to be able to use method reference when we are actually using methods that are already written for us, okay, instead of rewriting a lambda that just calls that method. So, here's an example of how we can achieve this. So we still use str.chars, so we still have our int stream to deal with, but this time we are breaking down our work into two separate steps, okay? The first step is I'm going to apply a map operation. It's just a different map method that I'm using here. I'm going to explain why in a second. I apply a map operation to all of the primitive data type int element of my stream. And only thing I do is really typecast them, convert them. So watch out, okay? I do two-level conversion here because I am being very explicit, let's say, extra explicit here in how I write the code. I am not trying to do anything implicitly and let Java, do it for me without me having to write it. I try to detail everything that's happening, every step that's happening here. So the code is a little longer than it should be, maybe, but at least you're going to understand exactly what's happening. So let's take a look at this lambda. This lambda takes ch. Ch is going to come from the int stream, so ch is an int. The first thing I do is I convert this int value into a char value, okay? Now I call the value of static method from the character class, okay? So character is a class that is a wrapper around the char primitive data type. And I pass to it a character, so that's why I pass to it a char. That's why I converted the int into a char. I could have let that be done by implicit conversion, but I've just made it explicit here. And now this value of method gets a char value and builds a character object that wraps around that char value. And the result of this is the lambda returns the reference to that newly built character object. So we went from an int to a character object. So we went from a int stream as input to map to object, map to obj method, and the output of it is a stream of character, so a regular stream of reference data types, right? That's why this method is called map to obj, map to object, okay? The idea of map is that when you apply the traditional map, you apply map to a stream of something and you produce a stream of something. So the traditional stream class, a generic stream class that is meant to work on reference data type. Well, here, the map to obj method belongs to the int stream class because that's what we have as the input here. And it allows us to generate at the end a regular stream, a stream of objects. So we go from an int stream, that is a stream of primitive data type, back to a stream of object. And then we can do for each system.out println, and it's going to separate, the step where we do the typecasting from the step where we just apply a method that already exists. So we are capable to here use, system.out println method reference. Okay. So I put here a link on an entry in Stack Overflow that's going to give you other example of why we need to map actually those into object, etc. So what do we have now? So we are back to the point where we have a fully stream style approach to solving our problem. So we can replace, things that are very basic lambda, like here's another example here by their method reference. We can do the typecasting on the fly as a separate step from actually displaying things. So that means that if we are trying to parallelize, for example, that means we can actually in parallel do all the typecasting that we want and then apply the for each terminal operation and then display element in the order of the sequence as soon as they become available. Okay, so we are back to the full functional stream-based style of programming, and here is another example of what we can do. Now that we are back in this groove, we can filter things, for example, based on the character isDigit method. So we can decide, I'm going to keep only the character that encode a digit from 0 to 9. And then I'm going to display them. And of course, we are back to basic operation here. So here there is an implicit typecasting of ch from int to char because the parameter of isDigit has to be a char, okay? So that's done automatically by Java. So if it's done automatically by Java here and there's no typecasting necessary here afterward, then I can replace by method references and I'm done. So we have seen so far different examples of what is called parameter routing. Parameter routing is just the ability of Java to automatically determine what to do with the one parameter that comes out of a stream when you try to, for example, map a lambda to that stream and use a method reference. Okay? So parameter routing has to do with how method references work. Okay, it's a simplified notation that allows us to avoid having to write a full lambda expression, okay? But because it's a simplified notation, there are some assumptions that are made by Java in how to expand that simplified notation into a full lambda or a full call to the method, okay? So that's what we are going to look at in this table here. So the first column of the table represents the type of lambda expression that we have made so far, and that we have been able to successfully replace by method references. The method references that correspond to each of the lambda expression are shown here in the second column of that table. Okay, so we are going to look at four examples of lambda expression and three different types of method. So this is the information in the third column. You can see that the first two lines of that table, correspond to static method of a class. Okay, the isDigit method is a static method of the character class. The print char method is a method that we wrote from a class that we also provided, which is named iterate string. So whether it's a library class or a class that you wrote doesn't matter, okay? You can reference static method of any class using the syntax name of the class, colon, colon, name of the method. So in both cases, the same syntax is used. When you write things like this, what is of interest to us is we know that this lambda is going to get a parameter from a stream, okay, an element of the stream at a time. This element, this parameter, is represented by ch in our lambda expression. So the question we have is, what happened to ch? How is this parameter routed through the call to the method reference? Well, there are two things we need to consider, okay? One thing to consider, let's start by the rightmost column, is do we pass actually the lambda parameter ch as a regular parameter to the method we are calling? And in those two examples, yes, that's exactly we do. So the ch that you have here as the entrance of your lambda, as parameter to your lambda, is automatically passed, just like you can see on the when we write the full lambda expression, is passed as first parameter to the method you are calling, okay? And that's okay because a static method, unlike, instance method, does not have to be called on an object. You know that when you call an instance method, you always have a variable s, for example, that is a reference on a string object, and you say s dot as the name of your method. So you call a method of the class string on an instance, a specific instance of the class string, an object, okay? And you use a dot notation to do that. Here, we are using static method, so those methods do not expect what is called a target object for their invocation. They can be called out of the blue, and we just have to pass them one parameter if they actually require a parameter. So that's exactly what we do with parameter routing automatically here. So that brings us to our second example, okay? Our second type of method here in the array, in the table that you see on the slide, is instance method of a class. Examples? Well, when we have a lambda expression like name arrow name.to uppercase, okay, what we are doing is we take a parameter name, but unlike the two previous examples in the table, we do not pass name as parameter to the method to uppercase. We use name as the target of the invocation of the to uppercase method. The syntax for the method reference is the same. Okay, you take the name of the class, string, colon, colon, to uppercase. Java is just smart enough to realize that to uppercase is an instance method of the class string. Therefore, it needs an object of class string. It needs a reference to an object of class string to be called upon. And it's going to identify that your name here, your name parameter for the lambda, is such a reference. So it's just going to use it to call the method on it. And there's no need for parameters to the to uppercase method, right? The method is just called on an object. So this is what the two last columns summarize. Do we need a parameter? No, not applicable. Do we have a target? Yes, we have a target for the invocation of the instance method, which is actually the parameter of our lambda expression. Okay? So parameter of the lambda expression, keep in mind, that's one element of the stream. And then we have this last example, which is a little bit different, okay? Let's start with what type of method this is supposed to represent. It's an instance method of a static field. Okay, so how do we write the lambda? The lambda would be ch, for example, a row system.out println ch. So that looks like, the first example that we considered actually in this table, right? The ch parameter from the lambda is not going to be used to call a method on it. It's going to be used to be as a parameter, as a regular parameter from a method. The notation system.out colon colon println looks the same, okay? So it's an instance method, which is the second type of method we considered. The syntax looks really like the first example we considered. So what's going on here? So what's going on here is that when we write system.out colon colon println, on the right-hand side of the colon colon, we specify a method name, okay? On the left hand side of the colon, we are not specifying a class name. And this particular example is particularly confusing, as a high probability of mischief there, because system is actually the name of a class, right? Start with an uppercase. So yes, we start with a class name, but then we do .out, and .out refers actually to a static field named out that is defined in the class system. So instead of system.out, we could have something like, x, assuming that x is a reference variable that holds a reference to an appropriate object, okay? So the bottom line is that, yes, the notation system.out makes you think that you're using a class, but no, actually system.out is just a reference to an object. So this is new. We can actually use method reference syntax to specify I want to refer to the println method as called on the system.out object. So at this point, the ch parameter of your of lambda is not going to be used to call the println method on it. Okay. Now we already have an object system.out on which we can call println, but the ch parameter is going to be used as a regular parameter during the method call. So that's what the last two columns summarize, right? The ch parameter of the lambda is used as a parameter for the method call, and the target of the method call not applicable. We're not going to use the ch parameter of the lambda for that. We already specified we want our method to be called on an existing object that is system.out. All right. So we are going to cover one more case of parameter routing a little bit later, but you can see that there are already 3 base cases here that are going to cover a large amount of all the use case you are going to encounter, okay, when you're trying to use method references. And they show that Java is actually pretty smart at understanding what to do with your stream element, given a specific method reference. So if you understand those rules, if you understand how Java thinks actually when you write a method reference, then you are going to be obviously able to write appropriate method reference, correct method reference, okay? If you are not aware of those rules, then you are like trying to guess, well, I think I can get away with writing string : to uppercase, and I have the feeling that it's going to work. Well, forget it, okay? You really need to understand how Java is going to interpret what you write. Otherwise, it's not programming, it's wishful, hoping. So these are the 3 rules we have for now. We'll add one more, but there's one more thing I need to add right now before we stop for this session. The thing I have to add right now is a little bit of a warning, a little bit of a caveat in this system. Based on what we exposed so far, if you have a static method in a class and you have an instance method in the same class, okay, both have the same signature. So same signature means same name, same number of parameter, and same data type for each of the parameters, okay? Well, then Java is not going to be smart enough to figure out what you want to use when you use the notation, the method reference notation, name of the class, : name of the method, because there are 2 possibilities. That same notation could be used to reference the static method, in which case, your parameter from the lambda is going to use to call the method on it, or it could be used to reference a static method, in which case you just pass whatever you get in the stream, as parameter of the method, and you don't need to call that method on a specific object, okay? So that's called a method collision. You're going to get compilation error, so it's going to be detected early on, which is always a good thing, and you have to make sure that you avoid that. So if you are in a situation like that, well, then you cannot really use the method reference notation. You have to go back to actually expanding your method reference into a lambda, and be clear about whether you want to pass the parameter of the lambda as parameter or as target object for invocation, okay? Now, there are some cases where, and these are a little bit of weird cases. For example, you can have a method that is static. So that means that you don't need to use a lambda parameter to call that method on that object. But at the same time, it doesn't take a parameter. So you don't need either to pass, what you get from the stream as parameter to that method. It's kind of a theoretical construct here, this example, because it really does nothing if you think about it, okay? You are trying to reference a method that doesn't take a parameter from the stream, that doesn't use what's in the stream as parameter, and that doesn't use what's in the stream as target for invocation. So the question is, what does it do? Okay, so it could be a method that just displays hello world, and it displays hello world regardless of what's in the stream, and it displays it once for every element in the stream. You just don't need parameter routing because technically there's no parameter to route at all there. Okay, so beside those kind of weird examples, there's no concrete example, pragmatic example where you are going to be able to get away with a method collision, situation and say, well, it still makes sense. No, generally those situations do not make sense. You have to just solve them by expliciting the lambda expression as opposed to trying to use the method reference notation.